Good morning. So we are going to continue with compound angles, and that's how we summarize them for sine A plus B, sine A minus B, the cos and the tan respectively. So we are going to prove how we come up with that and how we summarize it up like that. And so we shall first of all sketch that diagram, because if we do not prove this, you'll ask us where it comes from. So you'll observe that once the angle SPQ is A, then the angle USP is also A because they are alternating interior angles. And the angle UTS will be also equal to A because TSU is 90 minus A. And so I hope you understand the simple geometrics there. That's how we come up with those angles. And then once we consider TPS being B, we shall obtain for the first compound angle sine A plus B, which is equal to the opposite, which is QT over PT. And once we solve for QT, we observe that QT is equals to QU plus UT. And remember that QU can also be equal to SR because that is a rectangle, and so the opposite sides are equal. Yet SR can also be expressed in terms of sine A. If you observe, sine A is equals to SR over PS. So once you make SR the subject, you obtain that. Also, you'll observe that PS can be expressed in terms of cos B. Cos B is simply equal to PS, which is its adjacent, over PT. Now, once we put all those concepts together, replacing for QU and UT, you'll observe that UT is equals to ST cos A, but also ST can be expressed in terms of sine B. If you observe critically, it is equal to opposite over hypotenuse, and opposite is ST and hypotenuse is PT, because angle TSP is 90 degrees. Hope you are following. Get a piece of paper and follow critically. See where they come from. So we can now obtain QT, which is QU plus UT. However, QU is PT cos B sin A, and UT is PT sin B cos A. You'll observe that PT is a common factor, so we pull it out and we shall remain with cos B sin A and sin B cos A. So it's just a matter of rearranging them. And once you replace for QT, where we are having sine A plus B, you'll obtain our first compound angle for sine A plus B, which is equal to sine A cos B plus cos A sine B. And so we can now move on to cos A plus B being equal to PQ over PT. You observe that adjacent over hypotenuse. I'll not go into the one for sine A minus B. You can prove that. However, you'll obtain sine A minus B equaling sine A cos B plus cos minus cos A sine B. And so for cos A plus B, we have already seen that it is adjacent over hypotenuse. However, its adjacent PQ it can be expressed in terms of PR and QR, which is PR minus QR. And you also see that PR can be expressed in terms of cos A. Cos A is equal to PS. Cos A is equal to PR, which is its adjacent, over PS. So if you make PR the subject, you'll obtain that. PS can be also expressed in terms of cos B, and once you put it up there, you'll obtain for PR equaling PT cos A cos B. We shall do the same for QR, because we want to express PR and QR in terms of PT cos A and cos B, or sin A and sin B in terms of those angles. So once we observe critically, you'll see that QR is the same as QS, because that is still the same rectangle and those opposite sides are equal. And so US can be observed that it is equal to TS sine A if we consider that upper triangle. And TS can be also expressed in terms of sine B using the bigger triangle, that is PT sine B. And therefore QR is equal to PT sine A sine B. And once we put it in the equation for PQ, you'll obtain PT cos A cos B minus PT sine A sine B. PT is a common factor, you pull it out, and once you replace for PQ in our equation for cos A plus B, you'll obtain cos A equaling cos A plus B equaling cos A cos B minus sin A sin B. That is the compound angle for cos A plus B. Do not worry about this because they are written in the logbook, so there is no need for deriving them in an exam. You can simply get your logbook. It's about at 7,000 if I quote correctly. You can get one, the NEB question bank, and it is very legal to enter with it in an exam. Okay, so do not get worried about that.
I don't think. I think it's manageable.
So we can now obtain for tan A plus B. Remember that tan A plus B can also be the same as sin A over sin A plus B over cos A plus B. So when you replace for sin A plus B and cos A plus B, you'll obtain the compound angle for tan A plus B. So as we divide through every part of that particular expression by cos A cos B, yeah, I'll explain this ahead there when you start doing examples why we do that, and it is also very normal in algebra. You'll observe that once we start the algebra videos. Okay, so as you divide every part of that by cos A and cos B, you'll obtain the first part cos B cos B So for the first part, cos B cancels out. You remain with sin A over cos A, which is tan A. Second part, cos A cancels out. Sin B over cos B is tan B. And the third part, cos B over cos B, that is 1. And the last part, sin A over cos A gives us tan A. And sin B over cos B gives us tan B. And those are the compound angles for tan A plus B. So for the negatives, can simply emulate that, we can simply copy that and put it down there. You'll observe that for the negative, the sign will only change from positive to negative. For cos, that expression, wherever there is negative, we shall turn it into a positive. And for tan, wherever there is a positive, we leave it a positive, and wherever there is a negative, we shall turn it into. And for a tan, wherever there is positive, we shall put negative, and wherever there is negative, we shall put a positive. I'll ask that you go and prove for those other angles. Using the same diagram, you can obtain that, which I'll not cover in this tutorial. So thank you.